So I needed a quick little tool so that I could take and dump the BIOS blocks from an Atom CPM disk. And I needed a way to get them over to my PC so that I could run them through Ghidra and get a nice disassembly from them. So I wrote a quick little tool in C and Z88DK here, using my EOS library here to take and read the first 6 blocks from a CPM disk and to immediately take and spit them out to my PC and do it over a TCP connection. The program itself is really simple. We have our 2 AtomNet devices that we need to talk to, the network and the disk, and all we're doing is we're setting up the commands for the FujiNet here to open the connection. If you know the format of the commands that you want to send directly to the FujiNet network device, you literally can take and spit them out directly in a string. In this case, it's the open command, and the open command expects 2 bytes after that. One to specify the mode for read and write. In this case, that's 0C. And the second byte specifies the translation. Since we want this to be binary, that's 0. And then we spit out a network URL that points to my PC over here. And we have a corresponding FujiNet command called close that just closes the connection. We have a buffer to hold the block that comes in from the disk, but we also have a buffer here for the write command, which is the inverse of the read command here. And the write command is formatted to where we have the write command and then the data we want to write after it. Since the length is part of the packet, we don't have to specify that. We just want to say we want to write something out the socket. So all we have to do is set aside a buffer, put W as the first character in it, and off to the races we are. At which point we can take and open the connection to TMA2, write out the connect string, send the data, which basically involves reading each block into the block buffer, and then sending it out by copying it to the write command. And notice the index here is not 0, but it's 1. It starts at the second byte of write command because we want to preserve that W that we put up there on top, but we want the block to wind up in the remaining 1024 bytes. Boom, done. And at that point, since the command is already formatted out and ready to go, we can literally point EOS write character device to it, to the network, write it out, and Bob's your uncle. We do this 6 times. And since we're starting at block 1, that's I less than or equal to 6. Okay. So once that's all done, we go ahead and close the connection ourselves, and then we say that we're done. Once Netcat realizes the connection is done, it will stop. So that makes things really easy for us on the PC side. All we have to do is run Netcat and pipe it out to a file, and the FujiNet will grab those 6 blocks, send it over the network, close the connection, and what we wind up with is our 6 kilobytes of data that correspond to the CPM BIOS. So let's see it in action. We go ahead and we can compile it. Oop, we're in source. We can make it, compile it, boom, great. Now all I have to do at this point to make it use it is to just take and copy it to my TNFS folder. Now you'll notice over here on the Atom side of things that we have Atom read BIOS already in slot 1 here. It's already pointing to my TNFS server and pointing to this image, and it's mounted read only. So anytime I take and make any changes, they will automatically be picked up. I don't have to remount anything again. So it makes for a very fast development cycle. I can take and do my changes over here, and then take and compile them, bring them over, and test them immediately as they come across. So in the second slot, we have a standard CPM 2.2 disk here. So all that remains for us to do now is for us to start a listening server on port 6502 and pipe anything that it sees over to a file called CPM BIOS. I'll call it .bin. And now it's listening, waiting for the connection. And when we take and boot, the connection's received, it sends the data over, closes the connection. Bob is your uncle. We now have a CPM BIOS file that is 6 kilobytes in length. And if we take and do a little finagling here to make this text just a bit smaller, oh, did I set that? Oh, defaults, that would be why. Oops. So let me change that to be twice as big there. We'll take that and pull that across. I want to give just enough space so that you can see the hex dump and have it not wrap around. If we actually do a hex dump here with CPM BIOS, we'll see that we have our CPM BIOS. And in fact, if we take and more it, we'll see and page it, you'll see there it is, our CPM BIOS with our jump instructions, everything nice and neat, and ready to do our disassembly. So with that, I'm going to take and end this video here and hope that this was informative for everyone to show you some of the power of little things that you can make with your FujiNet to move data back and forth, and things that you can basically build on the fly as you need them. So until next time, guys, have fun.